Hello everyone. Today we will discuss about the chi-square test. The symbol of the chi-square test look somewhat similar to x square. Chi-square test is a non-parametric test. Chi-square test is a statistical test and this test is used to compare observed result with the expected result. This test is also known as non-parametric test. In statistics, we generally deal with two types of tests, parametric test and non-parametric test. In parametric test, we consider the population. From the population, we draw the samples. From the samples or from the population, we find out the mean, variance or standard deviation. But in non-parametric test, we only compare the observed result with the expected result, and from that we draw the conclusions. So let's see that. So as I told, if the test is parametric, then it consider population, sample, standard deviation, etc. And if the test is non-parametric, then it is chi-square test. In parametric test, we deal with the mean, standard deviation, sample, population. Okay, so chi-square test is of two types. Type 1 is test for goodness of fit. Goodness of fit means whether the data satisfying the condition or not, that we check in this test. Means we check that observed data is matching the expected results or not. Chi-square test is generally used to compare the experimental result with the theoretical hypothesis. In this test for goodness of fit, only one variable or one factor exists. In null hypothesis of this type 1, we always assume whatever is given to us. And in alternate hypothesis, we say no to the null hypothesis assumption. The formula for the chi-square test is chi-square equal to summation of O minus E bracket square upon E. Here O is the observed frequency and E is the expected frequency. So what are the steps for solving this chi-square test? It will be solved in 5 steps. In first step, we define the null hypothesis. Null hypothesis will be whatever is given in the problem. In second step, we define the alternate hypothesis. In alternate hypothesis, we say no to null hypothesis. In step 3, we define or we calculate degree of freedom, which is n minus 1, and we finalize the level of significance. So if the level of significance is given in the question, then we use given value, and if it is not given, then we assume it. Once we get the degree of freedom and level of significance, then with the help of chi-square table, we calculate the value of chi-square alpha. So chi-square table look like this. So in the chi-square distribution table, the first column is of degree of freedom, and after that we have the level of significance in the remaining column. So if degree of freedom is 5 and level of significance is 0.05, then the value of chi-square alpha is 11.071. So like this we find out the values for the chi-square alpha. In step number 4, we calculate the chi-square. So we calculate it by using the formula chi-square is equal to summation of observed frequency minus expected value bracket square upon expected value. Once we get the chi-square and chi-square alpha, then in fifth step we conclude. So in conclusion, if the chi-square value or mode of chi-square is greater than chi-square alpha, then we accept alternate hypothesis and reject null hypothesis. So we reject null hypothesis and accept alternate hypothesis. And if the mode of chi-square is smaller than chi-square alpha, then we accept null hypothesis and reject alternate hypothesis. Let's solve first question. So here in the question, a die was thrown 132 times and the following frequencies were observed. So table is given, in that number obtained is given in the first row and the frequency is given in the second row. Test the hypothesis that the die is unbiased. So we are going to solve this with chi-square test, as no samples, population, variance, mean we are talking here. So this is a purely non-parametric test problem, and here the independent value is single. So that's why this can be solved with the test for goodness of fit. This is a type 1 problem. So in step 1, define the null hypothesis. So here the null hypothesis, we are going to assume that die is unbiased. Die is unbiased. In step 2, we define the alternate hypothesis, that we say that dice is biased. So as I told, that whatever is given, that we are going to assume in the null hypothesis. Here it was told that test the hypothesis that die is unbiased. So as it is, we have considered that in the null hypothesis that dice is unbiased, and in alternate hypothesis we are rejecting this. So we say that dice is biased. In step 3, we define or we calculate degree of freedom and we finalize the level of significance. So degree of freedom here will be n minus 1. So observed values are 6 here, 1, 2, 3, 4, 5, 6. So n is 6. So degree of freedom is 6 minus 1, which is equal to 5. And level of significance is not given. So we assume that the level of significance is 5%. That is 0.05. Now from the chi-square table, the calculated chi-square alpha is 11.070. Step 4. In step 4, we calculate the value of chi-square. So the formula for the chi-square is observed value minus expected value bracket square upon E and the summation of all this. So here expected value we will calculate by using this frequency. So expected value will be 15 plus 20 plus 25 plus 15 plus 29 plus 28 divided by 6. So the average value of this frequency will tell us about the expected value. So E is equal to 15 plus 20 plus 25 plus 15 plus 29 plus 28 divided by 6. This is equal to 22. Now to calculate this value, we prepare a table. So the observed values are 15, 22, 15, 20, 25, 15, 29 and 28. Then expected values are 22 for each one of this. Then the next one is O minus E. So 15 minus 22 is minus 7. 20 minus 22 is minus 2. This is 3. This is minus 7, 7 and 6. Then O minus E bracket square. So this is 49, 4, 6, 49, 49 and 36. And the last one is O minus E bracket square upon E. So this is 49 by 22. This is equal to 2.22. 7. 4 by 22 is equal to 0.1818. 6. Sorry, this is 9. So 9 by 22 0.4090. Then again 49 by 22, which is 2.227. Here also 49 by 22, which is 2.227, and 36 by 22 is 1.6363. If we add all this, then we will get the summation of O minus E bracket square upon E, and that value is 8.9087. This is nothing but our calculated chi-square. So in step 5, we conclude. So the chi-square calculated is equal to 8.9087, whereas chi-square alpha, which we obtained from the table, that value is 11.070. So by observation, we can come to know that chi-square, mode of chi-square is smaller than chi-square alpha. That is, we accept null hypothesis and reject alternate hypothesis. How we come to know this? If we consider the distribution, in the distribution, if we assume that this value is chi-square alpha, then this region is level of significance and this is the acceptance region. Now, if we are saying that the calculated chi-square is smaller than chi-square alpha, it means that the value lies somewhere in this region. So we accept the hypothesis. That's why we are accepting null hypothesis. If the value of this calculated chi-square is more than chi-square alpha, it means that the value lies in this region. So in that case, we reject the null hypothesis and accept the alternate hypothesis. But as in this case, the chi-square calculated is smaller than chi-square alpha, so we accept null hypothesis and reject alternate hypothesis. It means that dice is unbiased. This is what we assume in the null hypothesis. Thank you.